A hush in the southern sky settled like a veil woven from twilight itself, drifting slowly across the horizon with a softness that felt almost intentional, as though the evening had decided to cradle the world in silence. The air cooled gently, not sharply as before storms or sudden winds, but with the careful touch of something ancient pressing lightly on the atmosphere. People who were out walking felt it first, pausing mid-step without understanding why, sensing that a quiet that did not belong to ordinary night had unfolded above them. Even the birds, usually chattering their final calls before darkness, stilled on their branches as though listening for a sound too soft for human ears. The southern horizon dimmed in a way no ordinary dusk could explain. Colors softened into a muted gray that felt neither heavy nor threatening, but deeply patient, like a memory returning from far away. Those who looked up felt their thoughts slow, their heartbeat ease, their worries soften into something lighter. It was as if the sky had drawn in a long breath, and the world beneath it was instinctively matching its rhythm. The air tasted faintly of stone touched by night dew, and everything seemed wrapped in a quiet that encouraged reflection rather than fear. Animals sensed the shift more quickly than humans did. Dogs pricked their ears and then lowered their heads respectfully, while horses in far fields turned southward with a calm attention that suggested recognition. Insects that normally shimmered into their nightly orchestra waited, wings held still as though suspended by invisible threads. The hush did not silence the world through force, it soothed it into a quiet so complete that even the smallest rustle seemed too loud to disturb the peace. On a rocky hillside, a shepherd paused among his flock, raising his lantern instinctively though it was not yet dark enough to need it. The hush brushed over him like a cool hand settling gently across his shoulders, steadying him. He felt as though someone had whispered his name from far away, not urgently but knowingly, calling him into a moment meant to be remembered. His sheep, usually restless at dusk, moved more slowly, their soft bleats fading into contented murmurs as the quiet deepened around them. The stars began to shimmer earlier than usual, faint at first, then brightening with a kind of gentleness unfamiliar to the night sky. Instead of piercing through the dusk sharply, they appeared like distant embers, drifting upward from some cosmic hearth. Their light pulsed softly, as though responding to the hush that had settled across the land. Villagers stepping outside to fetch water stopped and stared, feeling a strangeness they could not name but did not wish to disturb. Along a quiet river, the surface of the water smoothed into a perfect ribbon of silver, reflecting the dimming southern sky with a clarity that looked almost fragile. Fish slowed their movements, drifting deeper into the cool darkness as though seeking shelter from a soundless lullaby. The sound of flowing water softened, becoming almost transparent, as if the river itself felt compelled to join the greater stillness that lay across the world. In distant grasslands, nomadic families paused their evening routines, turning their eyes toward the horizon. Fires crackled more softly, their flames bending gently as though bowing to something unseen. Elders exchanged glances that held both recognition and quiet wonder. They had felt skies behave strangely before, though rarely with such grace. The hush was not an omen of disaster. It felt more like the world had entered a moment it had been waiting centuries to receive. Far above, drifting in the thin layers of atmosphere, microscopic particles began to shift in synchronized patterns, responding to forces beyond ordinary air currents. They caught faint traces of silver light filtering from the higher sky, scattering it in delicate glimmers that no eye could see directly. The hush had touched these upper layers first, beginning a chain of stillness that now spread downward with patient precision. Mountains along the horizon stood quietly beneath the thickening dusk, their slopes losing their familiar colors and taking on tones of soft charcoal and pale silver. Cracks in the rocks and crevices in the cliffs seemed deeper in the unusual light, though nothing about them had changed. It was the sky's hush that altered the way the land appeared, giving everything a subtle depth, as though the world had become a painting brushed with gentle strokes. In a small cabin built at the edge of an ancient forest, An old astronomer lifted his head from his worn charts, feeling the shift before he saw it. Years spent studying the heavens had sharpened his senses not just to patterns of light and motion, but to the subtler moods of the atmosphere. He stepped outside, letting the hush fall across him like a familiar cloak. He inhaled deeply, feeling the air vibrate with something old, something rare. As he looked up, he noticed that the stars near the southern horizon seemed slightly displaced, their usual patterns softened as though a thin veil had been drawn across them. He removed his glasses, wiped them, tried again, but the change was real. It was not the distortion of tired eyes. It was the sky itself shifting, subtly bending the light in ways he had only ever theorized. He felt a ripple of excitement, the kind born not from danger but discovery. Back in the village below, families stepped out of their homes together, drawn outside without knowing why. Lamps glowed through windows with a dimmer warmth than usual, as though the flames themselves had been hushed by the sky's quieting touch. People spoke in low voices, aware that anything louder might feel out of place. Children whispered to one another, clinging to the hands of their parents though they felt no actual fear. The quiet invited closeness. The hush lingered like a delicate presence, neither rising nor fading, but simply existing with steady purpose. It smoothed the edges of worry in the minds of those who felt it, replacing it with a calm curiosity. Even the most hurried people found their steps slowing, their shoulders relaxing, their breath deepening. It felt as though the world had shifted into a softer rhythm, one normally reserved for dreams or faraway memories. Riverside reeds swayed gently even though no wind touched them. Their movements were so faint that one could miss them entirely, but they pulsed with the rhythm of the hush, bending in a pattern more like breathing than blowing. This subtle motion spread along the riverbanks, as if the plants themselves were acknowledging something immense approaching quietly through the folds of the sky. In the shadow of distant hills, a caravan paused as its camels lifted their heads simultaneously, ears flicking toward the south. Their handlers exchanged surprised glances, for such synchronized alertness was unusual. Yet the animals did not bray or panic, they simply listened, their bodies still but poised, as though waiting for a sound they somehow expected. The hush reached them too, gentle but unmistakable. The air thickened slightly, not with heaviness but with presence, as though it carried messages that could be felt more than heard. The scent of the night deepened, cool stone, distant rain, and something faintly metallic, like the echo of a forgotten storm. People found themselves inhaling more slowly, as though savoring the change without realizing it. Children pointed upward, noticing something adults hadn't yet, the faintest flicker of movement at the edge of the southern sky. Not a shooting star or drifting cloud, but a soft ripple, as though the sky were shifting its weight. It faded quickly, leaving behind a shimmer almost too delicate to perceive. The children blinked, unsure whether they had imagined it, but the feeling remained, something was unfolding. The hush deepened among the trees, settling into the forest like a slow fog. Leaves that should have rustled with even the lightest breeze remained perfectly still, and forest creatures kept to their burrows, sensing a calm that asked them to wait. The astronomer, now standing on the small hill near his cabin, felt the silence pressing around him with gentle intent. It was not the silence of emptiness, it was the silence before revelation. In the plains beyond, farmers paused beside their fields as the sky shifted from muted grey to softer silver, the gradient so subtle it almost went unnoticed. The hush blended with the twilight, creating a glow that felt almost weightless, like the beginning of snowfall without the cold or the clouds. People found themselves staring longer than they meant to, mesmerized by the unfamiliar beauty. Time itself felt different, stretched thin in a way that made each second feel slower and richer. It wasn't uncomfortable, if anything, it felt luxurious, like being wrapped in a warm blanket after a long day. This temporal stillness embraced the land, softening footsteps, slowing conversations, calming restless hearts. It felt as though the world had shifted into a deeper layer of existence. And then, as the hush reached its deepest point, the entire southern sky seemed to breathe a long, slow inhale visible in the faint ripple of silvered air. No sound accompanied it, no flash, no tremor. Just a subtle motion, like fabric lifting in a gentle breeze. Those who watched felt their hearts pause for a moment, caught between awe and a strange familiarity. The hush held them all, quietly preparing the world for whatever would come next. The idea of a black hole that could swallow galaxies unfolded first not as a fear, but as a quiet thought drifting through the vast corridors of the universe's imagination. It was the kind of idea that didn't shout or demand attention. Instead, it arrived like a soft shadow falling over the edge of a distant star, hinting at a magnitude almost too large for the human mind to hold. A black hole so immense, so incomprehensibly heavy, that entire galaxies could spiral toward it like leaves circling a drain carved by gravity itself. Such an idea shimmered at the boundaries of what we consider possible. The concept itself stretches the imagination thin, asking it to hold the weight of millions of suns crushed into a single point where space folds inward. To imagine such a black hole, one must picture gravity not as a force but as a slow, ancient hunger woven into the fabric of space-time. A hunger that bends light, warps galaxies, and reshapes the very architecture of existence. Even the largest black holes humans know, those millions or billions of times more massive than our Sun, are dwarfed by the idea of one capable of dragging entire star systems into its silent descent. But the universe is no stranger to extremes. Somewhere in the quiet corners of cosmic history, where galaxies formed in clusters and collided like drifting islands, the seeds of unimaginable black holes may have taken root. Imagine one born not from a single dying star but from the collapse of dense regions of primordial gas, massive clouds that never had the chance to ignite into stars. Such a giant would begin its existence already vast beyond comprehension, a dark shape forming in a cradle of early cosmic turbulence. As galaxies formed and moved, as clusters drifted and merged, such a black hole could drift too silent, invisible, patient. Over billions of years, it might gather mass from the chaos around it, wandering stars, interstellar gas, even smaller black holes. With each encounter, it would grow heavier, deeper, its event horizon swelling outward like a shadow expanding across space-time. Gravity, after all, only becomes more persuasive with strength, and such a colossal entity would persuade everything near it to fall inward. To even picture a black hole swallowing galaxies, one must imagine distances so large they lose meaning, and forces so strong they reshape reality. Imagine a spiral galaxy, hundreds of billions of stars, drifting gradually toward something no light can escape. As it nears, its graceful arms would twist into stretched ribbons of starlight, distorted by gravitational tides so powerful they turn structure into shimmering arcs. Entire solar systems would be peeled from their orbits, scattered like dust by winds stronger than physics can easily explain. Yet such an event would not be violent in the way humans picture violence. There would be no explosion, no booming roar. In the vacuum of space, even catastrophe is quiet. A galaxy drawn toward an impossibly massive black hole would move slowly, almost elegantly, across millions of years. Stars would glide, worlds would drift, light itself would bend into spirals of distorted brilliance. To any distant observer, it would look almost like a cosmic dance, beautiful, slow, and inevitable. The idea of such a black hole brings with it a strange sense of humility. It reminds us that the universe is not built to accommodate human scale or comfort. It is vast beyond measure, governed by laws that do not bend to our wishes. A black hole that could swallow galaxies doesn't need intention or malice. Its gravity alone shapes the fate of everything that strays too close. In that sense, it becomes less a monster and more a natural consequence of a universe that allows things to grow without limit. Still, The image lingers, a void so deep that even galaxies vanish into its silent throat. For scientists, such possibilities are not simply frightening. They are intriguing, opening pathways to new theories about how mass behaves on unimaginable scales. Could such a black hole form? Could it move from place to place, drawn by the slow drift of cosmic structures? Could it lie hidden somewhere beyond the range of our instruments, waiting in regions of darkness we have not yet explored? To understand this idea, one must also imagine the curvature of spacetime itself. Around a typical black hole, spacetime curves steeply, forming a deep well. But around a galaxy-swallowing black hole, the well would be so vast that even the shapes of nearby galaxies might be influenced by its presence. It would act like a sculptor of cosmic landscapes, pulling some structures inward while bending others outward into arc-like shapes astronomers call gravitational lenses. What makes the idea more profound is the passage of time. Over billions of years, galaxies drift like clouds, slow and majestic. A supermassive black hole with unimaginable gravity would not need to chase them. Sooner or later, the cosmic currents might carry one within its reach. A single gravitational nudge, a slight shift in momentum, could set a galaxy on a path toward the darkness, altering its future in a way that does not reveal itself until eons later. As the galaxy approached, the first stars to feel the pull would be those at the edges, where gravity is weakest and stability most fragile. Their paths would warp first, spiraling inward like leaves caught in a whirlpool. Then the spiral arms would begin to elongate, thinning as stars migrated toward the growing center. Eventually, the heart of the galaxy, the dense cluster of stars surrounding its own central black hole, would feel the tidal pull of the far larger one, and the two gravitational giants would begin a slow, silent struggle. But in this struggle there would be no conflict, only merging. The smaller black hole would be drawn in, its mass adding to the colossal entity expanding at the center of the cosmic event. As they combined, a ripple of gravitational waves would spread outward, silent but powerful, warping spacetime in every direction. Worlds far from the collision would feel the faintest trembling, though they would never know its cause. Even as this happened, stars still orbiting far from the center would continue their journeys, unaware of the fate awaiting them. Some would be flung outward at incredible speeds, escaping the galaxy entirely as gravitational forces whipped them into the dark. Others would spiral inward, passing the event horizon with no dramatic signal, simply fading from the visible universe as though stepping into a doorway that allowed no return. The idea of a black hole swallowing a galaxy also challenges our relationship with light. Galaxies shine, their stars burning bright across millions of light-years. But inside a massive black hole, light loses its meaning. It cannot escape, cannot reflect, cannot carry news of what happens beyond the horizon. Whatever enters is not destroyed in the traditional sense, it becomes part of the black hole's gravity, woven into a place where time and space bend beyond recognition. For humans, this idea often stirs fear, but it can also evoke wonder. It reveals that the universe is not fragile, it is resilient, dynamic, endlessly creative. Galaxies vanish, but galaxies also form. Stars fall into darkness, but stars also ignite from collapsing clouds. The universe is a cycle of creation and transformation on scales so grand that the loss of a single galaxy is barely a whisper in its timeline. And if such enormous black holes can exist, and some theories suggest they might, then somewhere, perhaps in the distant corners of the cosmos, entire regions of space may already have been reshaped by their gravity. Perhaps galaxies have vanished into them long before humanity's earliest ancestors walked the Earth. Perhaps, in the darkness between the brightest clusters, something enormous drifts, older than stars, patient beyond comprehension. The idea also invites contemplation. What does it mean for something to be so massive, so dense, that it warps reality itself? What does it mean for darkness to be not emptiness but presence, a presence so strong that even light, the fastest traveler in the universe, bows to it? A black hole of this scale becomes a reminder that even in vastness, there are limits, edges, boundaries beyond which familiar rules dissolve. And yet, despite the enormity of such a concept, the universe remains balanced. These giants do not roam freely in search of destruction. They drift according to gravity, shaped by the same laws that hold Earth in its orbit. Their existence, if proven, would not threaten the cosmos but deepen its complexity, revealing that the universe allows for structures far stranger and more powerful than most imaginations dare to reach. To think of a black hole that could swallow galaxies is to accept that the universe is not built to be easily understood. It contains wonders and mysteries that stretch far beyond our scales of comfort. It is a place where even darkness has form and weight, where silence can be deeper than time, and where forces invisible to the eye can sculpt phenomena beyond comprehension. But perhaps the most humbling part of this idea is the stillness with which it unfolds. A galaxy spiraling toward such a black hole would do so over unimaginable lengths of time, not in minutes, not in years, but in millions of centuries. It is a slow story, one written in orbits and stretched starlight, in curves of spacetime and patient tides of gravity. And somewhere, drifting through this enormous theater, the idea itself becomes almost peaceful. A black hole swallowing a galaxy is not rage, it is gravity doing what gravity does. It is the universe folding back into itself, reshaping, renewing, continuing its vast and endless evolution, quietly, slowly, beautifully, and far beyond the limits of human sight. They begin with patience, because anything hidden in the dark asks to be understood slowly, almost respectfully, and a black hole is the darkest thing the universe knows how to make. Astronomers cannot place it on a scale or hold it up against a ruler, so they look instead at the space around it, at the quiet distortions it leaves like fingerprints pressed into the fabric of the cosmos. Stars that wander too close begin to move in strange loops, as though pulled by an invisible hand, and those movements become clues, soft, indirect, but powerful enough to reveal a mass that otherwise refuses to speak. Even the light around a black hole bends in a manner that feels like a whispered confession. Photons traveling in straight lines find themselves curved, slowed, or redirected as though their paths have been nudged by something strong and unseen. Astronomers track this bending, measure the angle, plot the arc, and from the shaping of that light they extract a weight, a mass so large it cannot belong to anything ordinary. The universe, in its own quiet way, tells them what they need to know. Sometimes a star orbits so closely that its path becomes a perfect notebook for astronomers to study. They map each turn, each acceleration, each pause in its shimmering dance. Over years, sometimes decades, they follow its journey until the pattern becomes undeniable. Only a black hole, sitting silently at the center, could force a star into such a tight and obedient orbit. The size of that orbit becomes another number, another clue slipping gently into place. Gas clouds are even more revealing. When they drift near, they heat up, swirl, and glow in colors invisible to human eyes but clear to telescopes tuned to wavelengths beyond ordinary sight. By watching how fast the gas spins, astronomers can estimate the gravitational grip tightening around it. That grip, unseen yet firm, speaks of a mass too enormous to ignore, and so they weigh the black hole by the speed of the gas it stirs like a spoon moving through a cosmic whirlpool. Some galaxies offer clues in the quiet pulsing of light near their centers. These pulses change in rhythm depending on the mass of the object anchoring the surrounding stars. A heavier black hole creates slower shifts, as if space itself were breathing with great, deliberate lungs. The timing of these breaths, the brightening and dimming, gives astronomers another way to estimate the invisible weight pressing against their measurements. When matter falls toward a black hole, it sometimes forms an accretion disk that radiates energy across the electromagnetic spectrum. Even though the black hole remains hidden, The disk behaves like a torch circling a bottomless pit. The intensity of its glow reveals how fast matter is moving, how tightly it is bound, and how deep the gravitational well must be. Astronomers study this glow with instruments designed to isolate the faintest signals, turning the swirling light into a quiet language of mass and motion. In some regions of space, black holes affect entire clusters of stars, shaping their movements on a grand scale. Astronomers measure the velocities of thousands of stars at once, then compare how these speeds shift as they approach or move away from the galactic center. The subtle changes in these vast patterns betray the presence of a black hole whose mass influences stars far beyond its immediate reach. It is like watching a flock of birds respond to an unseen wind, and from their motion understanding exactly how strong that wind must be. Radio waves provide another pathway. Jets of charged particles sometimes shoot from the poles of spinning black holes, moving at nearly the speed of light. By studying how these jets twist, brighten, or narrow over time, astronomers infer the power of the engine driving them. The power, in turn, corresponds to the mass of the black hole buried beneath layers of energy and shadow. It becomes another indirect but deeply telling measurement. Gravitational waves add a final, astonishing tool. When two black holes orbit one another and eventually merge, they send ripples through spacetime that detectors on Earth can register as tiny, fleeting tremors. The shape of these tremors, their frequency, their rise, their fading, carries within it the precise masses of the black holes before and after the merger. It is as though the universe momentarily hums the weight of what has collided. Each method alone would be uncertain, but together they build a picture as solid as anything seen with human eyes. Slowly, patiently, astronomers compile their observations, compare the curves of starlight, the motion of gas, the timing of pulses, the whisper of gravitational waves. Every piece fits into a quiet puzzle whose final shape is a number, an estimate of mass for something that refuses to reveal itself directly. And though they cannot look at a black hole the way one might look at a mountain or a planet, astronomers learn to trust the footprints left behind. They trace how space curves, how stars obey, how light falters, and from those signs they weigh the unseeable with remarkable precision. The process becomes a kind of gentle listening, like placing one's ear to a dark door and recognizing the presence and size of what moves behind it by sound alone. These measurements take time because the universe rarely offers hurried answers. A star's orbit may take years to complete, a gas cloud may drift slowly, a jet may shift subtly over decades. Astronomers learn to study these changes with the calm patience that cosmic mysteries require. The weight they are seeking is not small, and so the time it takes to uncover it cannot be rushed. In advanced observatories, teams gather around screens showing faint motions from galaxies millions of light-years away. Tiny changes in brightness, barely noticeable flickers, become part of long mathematical threads. Those threads wind their way into equations that reveal the gravitational influence of a massive, unseen object. Bit by bit, the numbers narrow until they settle on a mass that seems almost impossible for the mind to hold. Even the tools they use must be crafted with extraordinary care. Telescopes mounted in deserts or orbiting above Earth's atmosphere are tuned to detect the faintest distortions in space. The instruments must remain steady, precise, and patient, mirroring the astronomers who operate them. When they gather data, they treat it with the same gentleness they extend to the cosmos, understanding that every photon captured may hold part of the truth they seek. Sometimes, the weight of a black hole surprises even the experts. A galaxy smaller than expected may hide a black hole larger than imagined, challenging theories and forcing new questions to unfold. These unexpected results remind astronomers that the universe is not obliged to behave neatly. Instead, it behaves honestly, and honesty often comes in forms that require rethinking what was once believed to be certain. As the data accumulates, astronomers refine their models. They run simulations of stars moving under the influence of invisible masses, adjusting the numbers until the paths match the real motions observed. When the simulation finally aligns with reality, it provides a kind of quiet confirmation, a mathematical nod that the weight they have estimated is close to the truth. The beautiful irony is that the very darkness of a black hole makes it measurable. Its invisibility distorts everything around it, creating a signature that cannot be replicated by anything else. By studying the effects of this emptiness, astronomers define it more clearly than if it were lit by the brightest star. In its silence, it reveals as much as anything loud or radiant. And through all this, astronomers maintain a kind of reverence. To weigh something that devours light, that bends time, that hides behind horizons no message can cross, feels like an act of profound curiosity. It is science performed with awe, a balance between equations and wonder, between precision and imagination. Each new measurement adds to humanity's growing understanding of how the universe arranges its most powerful structures. Black holes, once thought mere theoretical oddities, now stand as measurable giants with definable weights and predictable behaviors. And yet, their mystery remains intact, because knowing how massive they are does not diminish the fact that they defy the ordinary rules of existence. In the end, astronomers weigh black holes not by touching them or seeing them, but by listening to what the universe says in the language of motion, light, and time. It is a language that speaks softly, requiring patience to decipher. But those who take the time discover that even the darkest regions of space leave trails of knowledge behind them. And so the weighing continues, quietly, steadily, lovingly, because every measurement of something so hidden brings humanity one step closer to understanding the vast, intricate, and mysterious machinery of the cosmos. It begins with a comparison so gentle you barely notice how enormous it really is. You imagine something the size of a mountain, then a planet, then a star, and each time you think you have come close to grasping the scale, the numbers slip through your fingers like water. A black hole of truly colossal size does not simply challenge your imagination, it overwhelms it, reshaping your sense of distance, mass, and width until ordinary language feels too small to hold the truth. In the quiet dark of space, it exists as a presence so vast that even metaphors tremble in its shadow. Astronomers speak of millions or billions of solar masses with a calm that masks their awe. A black hole weighing a few million suns is already staggering, but some go far beyond that, reaching into ranges that feel like exaggerations until you see the evidence written in the movement of entire galaxies. These giants become the silent anchors of cosmic neighborhoods, shaping the fate of stars spread across light years. And while numbers try to describe them, the reality remains something that presses against the limits of human imagination. You might try to picture one by stretching a mental image until it nearly breaks, a sphere so large that light itself bends around it like fabric pulled tight around a heavy stone. Yet even this visualization falls short. The scale is not just physical, it is gravitational, temporal, and deeply conceptual, each dimension contributing to its overwhelming magnitude. You could stack worlds, line up stars, or draw gigantic cosmic diagrams, and still you would only be tracing the faint outline of something too immense to visualize fully. When astronomers describe the event horizon of a supermassive black hole, they speak of regions so wide that millions of Earths could fit within them. Some are so large that if you tried to fly around their circumference at the speed of light, it would take hours, perhaps longer, an idea that makes the human mind hesitate, because nothing in daily experience prepares you for a journey around an absence that large. The universe contains nothing else quite like it, an object defined by a boundary you cannot cross and a size that seems designed to humble. These immense black holes sit at the center of galaxies, influencing the motions of hundreds of billions of stars. Their gravitational pull extends so far and so subtly that entire spiral arms trace graceful arcs around them. The scale becomes architectural, like a cosmic city built around a silent central tower whose height cannot be seen but whose presence shapes every street. The idea that something invisible can command such order adds another layer to its impossible size. Sometimes the numbers used to describe them lose all intuitive meaning. A radius of billions of kilometers or a mass equivalent to several billion suns can be written on paper, but the human mind folds inward trying to imagine it. Even astronomers admit that these figures become placeholders for something more profound, a reality so immense that comprehension demands relinquishing any expectation that the image will feel familiar or comfortable. It is an immensity that must be accepted, not fully visualized. To help people understand, scientists often compare these giants to more familiar objects. They might say one would dwarf our entire solar system, stretching far beyond the orbit of Neptune, or that another could swallow thousands of star systems without noticing. These comparisons offer a momentary sense of scale, but even they falter under the weight of the truth. A black hole of this magnitude is not merely big, it is beyond big, beyond any container the human imagination can reliably build. And yet, despite their enormity, these black holes remain astonishingly simple in a mathematical sense. They can be described by only a few properties: mass, spin, and sometimes charge. This elegant simplicity masks the immense actual size, creating a contrast between the clean precision of equations and the sprawling magnitude of the objects they represent. It is like holding a simple seed in your hand and knowing it contains the blueprint for a forest stretching across continents. The event horizon of a supermassive black hole becomes a border unlike any other. It is not a surface or a shell, but a threshold where space-time becomes so steeply curved that escape is impossible. To grasp its size is to imagine a doorway wide enough to swallow 1,000 suns yet impossible to touch, a boundary defined only by the behavior of light. This paradox, immense yet intangible, contributes to the sense that the scale of such an object transcends physical intuition. One way to sense its vastness is to imagine the gravitational well it creates. Even far away from the event horizon, its influence is strong enough to alter the orbits of stars thousands of light-years from the center. This kind of reach is not simply large, it is majestic. The entire galaxy becomes a map of the black hole's unseen architecture, each star's path traced by the invisible geometry of an immense gravitational presence. And if you imagine falling toward such a black hole, even hypothetically, the sheer scale becomes more striking. You could descend for hours, perhaps days, before approaching the event horizon, because the gravitational field extends so far outward. The horizon itself, this vast, invisible sphere, would grow in your view like a dark sun expanding across the sky. It would take up your entire field of vision long before you reached it, a slow eclipse occurring not from light but from the absence of light. Some of the largest known black holes, called ultramassive black holes, push the concept of size into new territory. Their event horizons may stretch across dozens of solar systems. In the quiet emptiness of space, they loom like gargantuan voids, shaping everything around them with a calm dominance. The idea that such an object exists and that the universe can support it forces you to reconsider your sense of limits. The cosmos is an artist unconcerned with moderation. Their size also affects the way time flows near them. For an observer far away, time near the event horizon appears to slow dramatically. This means that something falling toward such a giant could seem frozen in place, suspended at the edge of an abyss that takes up a region large enough to contain entire stellar neighborhoods. The mixture of immense size and temporal distortion creates an experience that feels almost mythic, as though the rules of reality are bending under the weight of the object itself. Despite being so huge, these black holes are quiet. They do not roar or rage unless matter is actively falling into them. Their stillness is deceptive, masking the enormity of their presence. If you were somehow able to stand at a safe distance and simply look at one, ignoring the impossibility of such an act, you would not see a monster thrashing or consuming. You would see a vast, perfect darkness surrounded by slow, swirling light, a giant that expresses its size not with movement but with silence. The steep curvature of space around such a massive black hole means that even light that passes nearby without being captured is bent dramatically. This bending produces distortions, arcs, rings, and illusions, cosmic mirages created by the enormity of the gravitational field. These gravitational lenses can focus the light of distant galaxies, making the black hole's vast influence visible in the warping of the universe itself. It is a size so immense it leaves fingerprints on the sky. Astronomers studying these giants often express a sober kind of awe. They are used to dealing with large numbers and vast distances, but the scale of supermassive and ultramassive black holes pushes even their accustomed sense of magnitude. The data they collect becomes a series of careful measurements that hint at something far beyond easy comprehension. They know the numbers are correct, but the size they represent remains astonishing every time it is revisited. It is not only the physical dimensions that matter, but also the energy associated with such mass. The gravitational potential of a supermassive black hole is so great that if matter spirals inward, even before crossing the event horizon, it can release extraordinary amounts of energy. Some of the brightest things in the universe, quasars, blazars, luminous galactic cores, are powered by these enormous beings. Their size, combined with their hunger, becomes a spectacle visible across billions of light-years. And yet, if a black hole of this magnitude were placed where our Sun is, it would not swallow the planets simply by existing. Its event horizon would be large, yes, vast beyond comfort, but the planets would continue orbiting as they do now, only around a different kind of central object. This fact surprises many people because it contradicts the instinctive fear tied to such a large void. The size is overwhelming, but it is not inherently destructive unless matter strays too close. When considering such scale, you begin to understand why galaxies form around these cosmic anchors. Their mass stabilizes the swirling chaos of star formation, organizing orbits and patterns on a galactic scale. Without them, galaxies might still form, but their structure would be looser, more chaotic, less defined. In this way, the immense size of a black hole becomes an architect's tool, shaping the very structure of the universe. Some of the largest ones have grown not only through the slow consumption of matter but also through the merging of smaller black holes across cosmic time. Each collision adds mass, enlarging the event horizon, expanding the scale to something even more difficult to imagine. Over billions of years, these giants become the sum of countless moments of gravity meeting gravity, darkness swallowing darkness, until the result is a single leviathan of pure mass. Even the distance from which one can safely observe such a giant becomes enormous. You must remain far outside the reach of its tidal forces, which, though gentle compared to smaller black holes, extend across massive areas. To witness it without being pulled in requires floating in space at distances that dwarf anything familiar. It becomes clear that the size of the black hole dictates not only its presence but also the safe perimeter around it, a vast bubble shaped by gravity's quiet authority. When artists attempt to draw or simulate these colossal black holes, they often struggle with the scale. The darkness at the center must be immense, yet the surrounding light must appear delicate, swirling in thin, beautiful arcs. The contrast between the smooth, endless void and the finely detailed motion of matter around it reveals the impossibility of fully capturing such enormity. Every image is a compromise, a human attempt to frame something that has no frame. Ultimately, the size of these objects teaches a quiet lesson about humility. You realize that the universe does not cater to human scale or comfort. It builds things that stretch imagination to its breaking point, not out of cruelty but out of abundance. The vastness of a supermassive black hole is not intended to intimidate, it simply exists, a natural outcome of cosmic processes running their course over billions of years. And so, contemplating one of these giants becomes an exercise in letting go of boundaries. The size will not shrink to fit your understanding. Instead, your understanding must expand to meet the size. You begin to see that imagination, like the universe itself, grows when stretched. The black hole remains immense, overwhelming, ungraspable, but in trying to hold its scale in your mind, you discover the vast, flexible capacity of thought itself. Its influence begins so softly that you might miss it if you weren't watching with patient, careful eyes. At the very center of its galaxy, the black hole sits in perfect stillness, exerting no dramatic outburst unless something wanders too close. Instead, it shapes its home with the gentlest long-term pressure, a guiding hand rather than a consuming mouth. Stars, moving through the darkness like silent lanterns, respond to its gravity in ways that appear almost choreographed. Their paths curve, align, and sweep in grand arcs that owe their elegance to the unseen mass at the center. From vast distances, the black hole feels less like a threat and more like a quiet anchor, a stabilizing weight that keeps the galaxy's structure intact. Without this invisible center, the swirling arms might lose their defined shape, drifting and unraveling in slow cosmic disorder. But with the black hole's steady pull, everything orbits in a way that seems almost serene, maintaining a rhythm that has persisted for billions of years. This calm gravitational guidance is one of its most subtle yet profound effects. Even the gas clouds, drifting lazily through the galaxy's inner regions, feel its presence. They move with a slightly increased sense of purpose, swirling gently toward the core but rarely plunging straight inward. Most simply shift their paths into graceful spirals, as if responding to a distant whisper. These delicate reorganizations in their motion shape star formation patterns, influencing where future suns will be born and how clusters will arrange themselves. The older stars near the center, those that have orbited the black hole for countless millennia, follow orbits that reveal its influence most clearly. Their movements become precise, predictable, and astonishingly stable. Astronomers study these motions, tracing them like brushstrokes on the canvas of space, each stroke depicting a subtle effect of the enormous mass lying hidden at the core. The black hole's quiet stability gives these stars a dependable path, almost like a cosmic heartbeat regulating their motion. Sometimes the black hole's influence reveals itself only through tiny variations in the velocity of light emitted from nearby gas. As gas orbits close to the center, it speeds up slightly, compressing its light into higher frequencies. Farther out, the light relaxes into softer tones. These gentle changes in color, invisible to human eyes but obvious to precise instruments, map out the hidden gravitational landscape surrounding the black hole. Even here, the effect is soft, subtle, almost like the faint shifting of a breeze. In some galaxies, the central black hole shapes the temperature of the environment around it. Though it may not feed often, the weak radiation from slowly drifting matter creates a warm pocket in the surrounding region. This heating prevents gas from collapsing too quickly, which helps regulate star formation. The black hole becomes a kind of cosmic thermostat, not by violence or force, but through a steady, mild influence that keeps the environment balanced over time. On larger scales, its presence contributes to the overall harmony of the galaxy's rotation. Without a massive object at the center, stars in the inner regions might spread out more widely, slowly loosening the tight structure of the galactic core. Instead, the black hole's gravitational pull ensures that these stars remain bound in their intricate dance, circling quietly around a point they can never see. This unseen guidance shapes the entire architecture of the galaxy. Even the dust that floats through the galaxy experiences the black hole's subtle pull. Particles that would otherwise drift aimlessly take on long, looping paths that eventually align with the general flow of the central region. Over immense stretches of time, this dust becomes part of broad streams that spiral inward, tracing delicate curves through the galaxy's interior. These curves, too faint for most telescopes to observe directly, form part of the black hole's quiet signature. Occasionally, the black hole influences magnetic fields within the galaxy. These fields, often tangled and chaotic, slowly become more organized as they respond to the controlled rotation near the core. The magnetic lines stretch, twist, and settle into patterns shaped indirectly by the black hole's gravity. Though the black hole itself holds no magnetic charge, the motion it orchestrates creates the order. It is influenced by proxy, subtle and far-reaching. Galactic centers often glow faintly in radio wavelengths, even when their black holes are dormant. This soft emission comes from particles swirling in the heated space around the event horizon, not from dramatic accretion or flares. The glow is like a quiet lantern burning in the heart of the galaxy, a reminder of the massive presence hidden within the darkness. This low-level activity gently affects the surrounding gas by providing just enough energy to shape its distribution. When the black hole rotates, and nearly all do, its spin subtly affects the orientation of the matter around it. Space-time itself twists slightly near a spinning black hole, causing nearby orbits to precess slowly. Over thousands of years, this gentle twisting becomes apparent in the arrangement of stellar paths and gas disks. It is a quiet but profound effect, the warping of space not through chaos but through steady, persistent rotation. In certain galaxies, the black hole helps maintain a calm environment by preventing runaway star formation. If too much gas gathers in the central region, the environment can collapse into intense bursts of new stars. But the black hole's gravitational influence helps distribute this gas more evenly, sometimes even pushing it outward through mild energy interactions. This keeps the galactic core from becoming too crowded or unstable. The black hole's quiet presence also influences the long-term evolution of its galaxy. Its mass determines how the central bulge grows, how the star population changes, and how tightly the inner regions remain bound together. Astronomers see a clear correlation between the size of a galaxy's central black hole and the structure of the galaxy itself, as though both evolved together in a slow, steady partnership shaped by mutual influence. Even when the galaxy is disturbed, perhaps by interactions with other galaxies or passing cosmic structures, the central black hole helps re-establish order. The stars and gas that become jostled eventually fall back into orbit around the core, guided by the black hole's unwavering gravitational pull. Like a calm center in a storm, the black hole provides stability, enabling the galaxy to recover its shape over millions of years. The black hole's quiet influence becomes especially apparent when astronomers compare galaxies with and without active centers. Those with powerful black holes often show signs of regulated inner regions, whereas those lacking such a massive core can appear more chaotic or unstructured. Even in silence, the black hole performs the role of an organizer, keeping the galaxy's energies balanced. On the smallest scales near the event horizon, particles move with intense speed, but their collective interaction creates a region of surprising predictability. This predictability radiates outward, adding a sense of order to areas far beyond the horizon. Each tiny particle's behavior contributes to a larger, calmer pattern. In this way, even the black hole's smallest effects ripple outward to shape its home. Over billions of years, the black hole gently collects stray matter, tiny fragments of dust, drifting atoms, solitary stars wandering too close. This slow accumulation affects the overall mass distribution within the galaxy. As the black hole grows, even subtly, the galaxy adjusts to the new mass at its heart, altering orbits and distributions in ways that remain almost imperceptible in the short term but become significant across cosmic time. In some cases, the black hole's quiet presence stabilizes the galaxy during minor mergers. When small companion galaxies drift inward, Their stars often become integrated into the larger structure without catastrophic disruption. The central black hole's mass anchors the system, reducing the likelihood of the galaxy tearing itself apart from gravitational chaos. This influence helps maintain galactic identity over vast stretches of time. As galaxies age, the black hole becomes a kind of historical record. Its mass tells astronomers how much matter has passed through the galaxy, how many stars have lived and died, and how much gas has flowed through the core. It becomes the sum of its home's long history, silently storing the narrative in its expanding event horizon. In this sense, the black hole is both an influence and a witness. The calm behavior of nearby stars also offers insight into the black hole's subtle influence. These stars rarely experience erratic motion. Instead, they glide in smooth paths shaped by the consistent gravity of the central mass. Their long-term stability contrasts with the dynamic environment farther out in the galaxy, where interactions are more chaotic. The black hole's steady pull creates a tranquil region of ordered motion. Even the shape of the galaxy's central bulge, its rounded, luminous heart, is influenced by the black hole. Stars near the center tend to follow orbits that create a slightly more compact and symmetrical distribution, forming a bright sphere around the hidden core. Though the black hole remains unseen, its presence is written in the very geometry of the galaxy's inner light. This quiet effect extends to the outer regions, too. Though the gravity there is weaker, the overall shape of the galaxy's rotation curve, how stars move at different distances, is partly governed by the mass at the center. The black hole's subtle pull becomes part of a larger interplay of forces that shape the galaxy's speed profile, contributing to a stability that persists across cosmic ages. Even when the black hole is active, sending out mild flares or gentle streams of energy, its influence often serves to reshape rather than destroy. Small bursts of radiation can push away dusty material, clearing the central region and allowing new structures to form. These soft outflows, though faint compared to the dramatic jets of more energetic black holes, still mold the inner environment with care rather than violence. And at the heart of all of this lies the simplest truth: the black hole's influence is constant. It does not flicker like a star or fade like a nebula. It remains the stable center of its galaxy, guiding everything around it with quiet gravity. Its effects are subtle, patient, and deeply woven into the fabric of its home, forming the silent architecture upon which the galaxy builds its luminous, spiraling life. The presence of a supermassive black hole at the heart of a galaxy is not a mere accident, it is a cornerstone of cosmic evolution. Its influence, though quiet, stretches across billions of years, shaping the trajectory of stars, gas, and even smaller black holes. By anchoring the galaxy, it provides a gravitational center around which structures form, drift, and settle. Without it, the galaxy's delicate spiral arms might unravel, its central bulge might fail to condense properly, and the balance between formation and destruction would tilt unpredictably. This gentle monster's mass dictates the pace of growth for its host. Regions near its event horizon respond differently from those farther out, and the differential gravitational pull creates an environment where star formation is regulated, not chaotic. Gas clouds that might otherwise collapse too quickly are guided into orbits that permit controlled bursts of stellar birth. Over cosmic timescales, this regulation ensures that galaxies do not burn themselves out in premature brilliance but instead maintain a more measured, enduring evolution. Even the smallest perturbations around a black hole ripple outward with long-term consequences. As stars are nudged slightly from their natural paths, orbital dynamics shift subtly, influencing the motion of neighboring stars. Gas flows bend, dust streams realign, and the distribution of angular momentum changes across the galaxy. These minuscule adjustments, almost imperceptible in the short term, accumulate over millions of years to produce measurable differences in galactic structure. Galactic mergers, a key feature of cosmic history, also unfold under the black hole's silent supervision. When two galaxies collide, the central black holes play a role in organizing the chaos. Their combined gravitational pull helps integrate stars and gas from both systems, preventing the cores from collapsing into disarray. In this way, even in violent encounters, the gentle monster serves as a stabilizing agent, preserving coherence across structures that might otherwise fragment irreversibly. The black hole's rotation adds another layer to its historical impact. Spinning black holes twist spacetime itself, creating a frame-dragging effect that subtly shifts the orbits of nearby matter. This effect influences the distribution of angular momentum in the inner galaxy, shaping the trajectories of stars and gas clouds over eons. Through this quiet manipulation, the black hole sculpts the flow of matter, leaving a long-lasting imprint on its cosmic neighborhood. Accretion processes, though often intermittent, also contribute to history. Even small amounts of matter spiraling into the black hole release energy that gently heats the surrounding medium. This energy can prevent runaway star formation, regulate the density of gas in the galactic core, and even trigger waves of new star birth further out. The black hole's activity becomes a subtle but persistent force in the galaxy's life cycle, guiding creation as much as it draws matter inward. Its gravitational influence extends far beyond the central regions. Stars at thousands of light-years distance still feel its pull, albeit faintly. This distant reach affects the overall rotation curve of the galaxy, contributing to a global structure that remains coherent over billions of years. The black hole's mass is not merely a number, it is a sculptor of cosmic architecture, a quiet hand shaping motion across vast scales. The gentle monster also provides a historical record. By measuring its mass, spin, and surrounding structures, astronomers can infer the galaxy's past, how much matter has been accreted, how many mergers have occurred, and how the central region evolved. Each supermassive black hole becomes a time capsule, preserving evidence of cosmic events long before human observation was possible. Its quiet presence tells a story that stretches across epochs. In clusters of galaxies, these black holes influence interactions beyond their immediate host. Gravity from a massive core can subtly alter trajectories of neighboring galaxies, guiding motions and contributing to the formation of large-scale structures. Over billions of years, the cumulative effect helps determine the shape of filaments, voids, and clusters in the cosmic web, connecting the life of a single galaxy to the broader history of the universe. Even dormant black holes leave their imprint. Once a massive object has accumulated, it continues to anchor its host regardless of activity. Stars and gas remain tethered to its presence, and the structural influence of its gravity persists. This long-lasting effect ensures that the galaxy's architecture carries the signature of the black hole's past growth and interactions, a persistent footprint in cosmic history. The gentle monster also regulates chemical evolution within the galaxy. By controlling the flow of gas toward the core, it affects where supernovae occur and how heavy elements are distributed. Elements forged in dying stars may be carried outward or trapped near the center depending on the gravitational dynamics influenced by the black hole. This slow redistribution shapes the chemical makeup of future generations of stars and planets. Supermassive black holes influence the formation of star clusters in subtle ways. Their gravitational pull molds the trajectories of dense clouds of gas, determining where stars are likely to condense into coherent clusters. This regulation helps maintain a balance between dispersed star formation and the creation of concentrated stellar populations, contributing to the long-term structural integrity of the galaxy. The gentle monster's energy output, even at low levels, drives galactic winds that can clear gas from the core. This process prevents the central regions from becoming too crowded with matter, reducing the risk of uncontrolled gravitational collapse. Over time, these slow outflows shape the distribution of gas and dust, setting the stage for continued star formation across a more stable environment. Its influence also extends to satellite galaxies orbiting the host. The black hole's mass contributes to the overall gravitational potential that governs their paths, subtly guiding their orbits and interactions. These effects can determine whether satellites remain bound, merge, or drift away, shaping the long-term structure of the galactic system as a whole. By regulating inflows of gas, the black hole indirectly controls the rate at which new stars form near the galactic center. Regions that might otherwise experience rapid bursts of star formation are slowed, allowing a more gradual accumulation of stellar mass. This pacing contributes to the long-term stability and evolution of the galaxy, demonstrating how the black hole's quiet effect orchestrates growth over cosmic time. Even cosmic dust responds to its influence. Tiny particles that would otherwise wander randomly are nudged into coherent streams, forming spirals, rings, and filaments around the core. These structures persist for millions of years, providing pathways for star formation and shaping the visual architecture of the galaxy. The black hole's pull, though invisible, acts as a subtle choreographer for matter on all scales. The gentle monster also plays a role in galaxy morphology. Galaxies with more massive black holes tend to have more defined bulges and tighter central structures, while those with smaller or absent black holes can appear more diffuse. This correlation shows that the black hole's influence is not just local but shapes the galaxy's overall form, reinforcing its role in the historical development of cosmic architecture. Over billions of years, the cumulative effect of these quiet interactions becomes profound. The black hole orchestrates orbits, regulates matter, stabilizes mergers, and influences chemical composition. Its presence ensures that the galaxy remains cohesive, balanced, and capable of sustaining ongoing star formation. This slow, persistent effect contrasts with the dramatic events often highlighted in cosmic storytelling, yet it is far more significant in shaping the long-term destiny of galaxies. Even the behavior of interstellar magnetic fields responds subtly to the black hole's influence. Twisting and stretching along with orbiting gas and stars, the fields help guide the flow of charged particles, shaping structures like filaments and jets. These magnetic effects extend the black hole's reach, influencing regions far beyond the event horizon in ways that remain quietly powerful over vast scales. The gentle monster also serves as a stabilizing force during galaxy collisions. While outer regions may experience turbulence, the central black hole anchors the core, preserving key structures and guiding material into new configurations. This stabilizing effect allows galaxies to retain coherent identities even after repeated interactions, ensuring continuity across cosmic history. Even when not feeding actively, the black hole acts as a central reference point for stellar orbits. Its gravity ensures that stars maintain predictable paths, which in turn stabilizes the distribution of angular momentum across the inner galaxy. This quiet guidance reduces chaos, allowing the galaxy to evolve in a more ordered and predictable fashion, demonstrating the profound influence of something that remains largely invisible. The gentle monster's effect on gas flows is particularly important for the long-term cycle of star formation. By influencing where gas accumulates and how it moves, the black hole determines which regions become fertile for new stars and which remain relatively quiescent. Over time, this selective shaping produces a galaxy with a balanced distribution of stellar populations, enhancing structural longevity. In clusters of galaxies, black holes contribute to broader cosmic history by affecting the motions of surrounding matter. Their cumulative gravitational pull can subtly direct flows of gas and stars between galaxies, shaping interactions and mergers on scales that span millions of light-years. Through these mechanisms, the black hole connects the fate of a single galaxy to the grand tapestry of the universe. Ultimately, the black hole's importance lies in its quiet persistence. It does not dominate through fire or force but through an enduring, steady presence. Its gravity organizes, regulates, and stabilizes, leaving a signature on every scale from individual stars to entire galactic structures. Over billions of years, this subtle influence becomes a defining feature of cosmic history. By understanding this gentle monster, astronomers gain insight not only into the life of a single galaxy but also into the evolution of the universe itself. Its quiet effects provide context for the formation of structures, the pacing of stellar birth, and the organization of matter across cosmic scales. In this sense, the black hole is not merely a destructive force but a central participant in the long story of existence, shaping history through patient, unseen influence. Even as we continue to study and discover, the black hole's influence reminds us that significance does not always roar. Some of the most profound forces in the cosmos operate in silence, guiding matter and shaping destiny in ways that only patience and careful observation can reveal. This gentle monster matters because it sustains the architecture of galaxies and preserves the flow of cosmic history. In contemplating its quiet power, we recognize a truth about the universe itself. The most lasting changes often come not from sudden events, but from steady, persistent influence over vast spans of time. The black hole, enormous yet subtle, teaches that cosmic history is written in whispers as much as in flashes, and that even darkness can shape the light that surrounds it. The universe hums a quiet song, one composed of gravitational whispers, shifting starlight, and the soft pulse of distant phenomena. Astronomers call it uncertainty, but it is also a lullaby, a reminder that the cosmos holds secrets that have not yet been revealed. Every observation, every measurement, is a note in a melody that stretches across time, and the black holes at the centers of galaxies contribute a deep, resonant bass to the song. Their presence is felt not through direct observation but through the subtle distortions they imprint on the fabric of space. As telescopes peer deeper into the sky, they encounter signals that are both familiar and strange. Stars wobble, gas clouds curve, and photons bend as they skirt the edges of massive unseen objects. Each of these distortions carries information, but never a complete answer. Scientists must listen carefully, like a musician deciphering the notes of an unfinished composition, aware that missing pieces could transform the melody entirely. The lullaby of uncertainty is gentle, yet persistent, inviting patient attention rather than hurried conclusions. Gravitational waves, rippling across the cosmos from distant collisions, add a haunting layer to the lullaby. Their arrival at Earth is a soft vibration, a subtle thrum against the instruments designed to detect them. Each wave tells of events that occurred millions or billions of years ago, yet their faint presence carries the weight of enormous cosmic energies. Black holes, especially the supermassive kind, are prime composers of these vibrations, their interactions writing messages across the continuum of space-time. Even the smallest deviations in star orbits near galactic centers contribute to the song. As stars dance under the pull of massive unseen centers, their paths provide clues, like the delicate tremors of a harp string vibrating under unseen fingers. Observers must interpret these tremors carefully, tracing patterns that hint at the hidden gravitational architecture. The lullaby is slow, almost imperceptible, but within it lies a narrative of cosmic forces shaping entire galaxies over eons. Some clues come from the light itself. Photons bent, red-shifted, or absorbed provide a subtle score of motion and energy. Each wavelength carries a story, and by listening across the spectrum, from radio waves to X-rays, astronomers weave together threads of information into a coherent understanding. The lullaby's melody is composed of many instruments, each adding depth and richness, and each requiring time and patience to interpret fully. There is a rhythm to this cosmic song that mirrors the cycles of observation and discovery. One night, a telescope may reveal a subtle flare near the core of a distant galaxy, a brief crescendo in the otherwise quiet melody. Years later, another signal may align, adding a chord that was previously missing. The full composition takes centuries to appreciate, reminding us that uncertainty is not absence of knowledge, but a stage of listening, a way to attune ourselves to the universe's intricate patterns. Even theoretical models contribute to the lullaby. They are like sheet music, attempts to predict the harmony before all notes are heard. By comparing simulations with observed phenomena, scientists adjust the melody, refining predictions while remaining open to unexpected variations. The black holes, especially those whose mass and spin are still uncertain, provide unpredictable flourishes, challenging assumptions and inviting deeper engagement with the song of the cosmos. Sometimes the lullaby becomes more dissonant. Observations that contradict expectations, stars moving in odd orbits, gas behaving unpredictably, energy emissions at unexpected levels add tension to the composition. These moments of uncertainty are not failures but essential components of the melody, prompting scientists to rethink assumptions, refine instruments, and listen more closely. The lullaby's beauty lies in this interplay between expectation and surprise. The passage of time itself is a part of the melody. Observations made decades apart reveal slow crescendos or shifts in pitch, as stars complete long orbits and gas clouds drift along winding paths. Astronomers must remain patient, understanding that the lullaby unfolds across scales far larger than human lifetimes. Each new measurement adds a layer, creating a richer texture that deepens comprehension and heightens appreciation of the universe's subtle rhythm. Even dormant black holes participate in the composition. Their gravitational influence shapes matter without visible drama, bending the paths of stars and gas in ways that are measurable yet understated. This quiet contribution forms the backbone of the lullaby, a persistent harmony that anchors the more flamboyant signals of active accretion or energetic jets. Without these quiet giants, the melody would lack its depth and continuity. Instruments themselves become extensions of the human ear, finely tuned to capture the faintest elements of the song. Space-based observatories isolate photons from interference, ground-based detectors measure gravitational vibrations, and arrays of telescopes collaborate to triangulate sources. The technological care mirrors the patience required for listening, as every piece of data contributes to the evolving understanding of what the black holes and the universe at large are singing. Future listening promises new dimensions to the melody. As detectors become more sensitive, as telescopes peer further into the cosmos, previously inaudible notes will emerge. Perhaps waves from distant mergers or subtle distortions of light will reveal black holes previously invisible. The lullaby of uncertainty will gain new complexity, and astronomers will learn to interpret rhythms that were once beyond reach, expanding our understanding of the cosmic orchestra. Each observation contains both clarity and ambiguity. While some signals can be traced directly to mass, spin, or energy output, others resist interpretation, leaving faint echoes that suggest phenomena yet unknown. Scientists learn to embrace this ambiguity, recognizing that the lullaby's purpose is not merely to inform but to invite continual listening, reflection, and discovery. The unknown becomes a necessary counterpoint to the known. Even the distance of black holes amplifies the sense of uncertainty. Many lie millions or billions of light-years away, and the signals reaching Earth are attenuated by space-time, redshifted and scattered. Yet these faint whispers are sufficient to reveal patterns and infer properties, demonstrating that even distant murmurs contain meaning. The lullaby stretches across space, carrying a sense of scale and wonder that frames the human quest for understanding. The interaction of multiple black holes adds harmony and counterpoint to the composition. Binary systems, mergers, and gravitational interactions create overlapping waves, producing interference patterns that are rich and intricate. By disentangling these overlapping signals, astronomers uncover layers of complexity, revealing not only the properties of individual black holes but also the dynamics of entire galactic centers. The lullaby becomes a symphony, composed of multiple, interweaving voices. Subtle fluctuations in background radiation also contribute to the song. The cosmic microwave background, along with diffuse emissions from dust and gas, forms a soft ambient layer that interacts with the signals from black holes. Observing how these backgrounds are bent, amplified, or absorbed provides additional notes in the melody, reminding listeners that every part of the universe participates in the composition. Astronomers approach this music with humility. The more they learn, the more they understand how much remains undiscovered. Each piece of knowledge deepens appreciation but also exposes new questions. Black holes, in their mystery, represent the ultimate unresolved note, a motif that persists, unresolved, challenging human understanding while guiding the search for clarity. In some cases, signals arrive unexpectedly, as if the universe improvises. A sudden flare, a jet of particles, or a gravitational wave from a distant merger can provide an unanticipated flourish. These surprises remind scientists that while models and predictions are valuable, the lullaby contains improvisation, moments that defy expectation and demand fresh interpretation. Listening remains a dynamic, adaptive process. The flow of time itself is a conductor of the melody. Slow orbital changes, gradual energy releases, and the long-term evolution of galaxies act as tempo, pacing the narrative of observation. Human perception of these events is necessarily compressed or delayed, but careful monitoring allows astronomers to track the rhythm across millennia, detecting patterns that would otherwise remain invisible. Time is both participant and measure in the lullaby. Even phenomena yet to be imagined contribute to the sense of future listening. Black holes may interact with dark matter or other exotic forms of energy in ways not yet understood. Each new discovery adds potential layers, suggesting that the lullaby is not a finite composition but an ongoing work, expanding as human understanding deepens. The future of listening holds as much promise as the accumulated wisdom of past observations. The quiet influence of black holes in galactic centers remains a central motif. Their steady gravity, invisible yet pervasive, organizes matter and shapes structures in ways subtle enough to be missed but profound over long periods. Their contribution to the cosmic melody is understated yet essential, providing harmonic stability against which more dramatic events play. Even in their violent episodes, when matter falls rapidly and jets of energy erupt, the black holes contribute to the lullaby without dominating it. These events are transient crescendos, adding contrast and tension, reminding listeners that chaos and order coexist. The lullaby embraces both the quiet and the dramatic, the persistent and the fleeting, reflecting the duality inherent in the universe. The search for understanding is itself part of the melody. Each observation, each theoretical model, each refinement of data represents humanity's attempt to harmonize with the cosmic song. By listening attentively, scientists translate uncertainty into knowledge, yet they also remain aware that some notes will forever remain elusive, preserved in the depths of space-time. Astronomers often speak of future listening, imagining instruments yet to be built, techniques yet to be refined, and signals yet to arrive. Each new advance allows humanity to hear more of the composition, revealing subtleties previously drowned out by distance, noise, or technological limitation. The lullaby extends into the future, inviting successive generations to continue listening, interpreting, and discovering. Uncertainty is not a flaw but a defining feature of this lullaby. It reminds us that the universe is vast, complex, and ever-changing, and that understanding is a process rather than a conclusion. Black holes, with their immense gravity and hidden depths, exemplify this truth, shaping galaxies quietly while leaving questions that will guide observation for centuries to come. Even as models grow more sophisticated, the sense of wonder remains. Observing how matter bends, light distorts, and time stretches near black holes, astronomers find themselves enveloped in the lullaby's depth. It is a melody that stretches comprehension, blending known and unknown into a continuous, evolving harmony that calls for attention, patience, and reverence. The composition is not static. As discoveries unfold, as gravitational waves are measured, as distant black holes are identified, the lullaby shifts in subtle ways. It is alive, dynamic, and infinitely intricate. Its persistence and variability remind us that the universe is not simply a collection of objects, but a living symphony in which uncertainty and potential coexist. Ultimately, listening to this lullaby is an act of humility and curiosity. The gentle monster at the heart of galaxies, the supermassive black hole, contributes a profound voice to a composition that stretches across space and time. By attuning to its influence, scientists learn not only about the universe's structure but also about the nature of knowledge itself, how understanding grows from careful listening to what is felt, suggested, and imagined. The lullaby of uncertainty encourages patience, reflection, and openness. As humanity continues to develop new instruments, explore deeper regions of space, and detect subtler phenomena, the song will become richer and more intricate. Each note, each resonance, adds to a symphony that has been unfolding for billions of years, reminding us that the universe is an ongoing performance, one in which we are both audience and participants. Even in its most silent moments, the melody persists. The black holes, galaxies, stars, and gas clouds all play their part in this continuous, evolving lullaby. The quiet of space is deceptive, for within it flows a rich, unending song of gravity, motion, and time, one that invites attentive listeners to remain present, patient, and ever curious. And so, the lullaby continues, a composition of uncertainty, wonder, and discovery. It stretches across cosmic history, embracing the hidden, the immense, and the mysterious. Those who listen carefully learn that understanding is an ongoing process, and that the gentle monster at the center of galaxies is both a source of stability and a guide to the unknown. Its song, ever present, calls for attention, patience, and awe. In listening to this lullaby, humanity gains more than knowledge. We gain a sense of connection to a universe far larger than ourselves, one in which quiet influence and subtle forces shape the grand story. The black holes, though unseen directly, offer a reminder that even the most hidden elements play a defining role, and that future listening will reveal deeper layers of a melody that has been resonating since the dawn of cosmic time. The lullaby of uncertainty is eternal. Each discovery adds a new note, a new rhythm, a new texture. Even as questions remain, the act of listening transforms mystery into understanding, and observation into insight. The gentle monster's song continues, carrying lessons about patience, persistence, and the beauty of the unknown, guiding those who are willing to attune themselves to its quiet, persistent, and deeply resonant tune.